Hello, today I am going to discuss about the different types of moisture present in any grains. At any stage of grain, the grain moisture should be in any one or combination of three moisture. So one you see, the first one is your, it may be either bound moisture, second one is your unbound moisture, third one is your free moisture. The three types of moisture present in any grain. So simply once you start drying or remove any dehydration or drying, so initially the moisture present in the grains or any solid products, that moisture remove as a from the free moisture content. There is excess amount of moisture, free moisture remove first, then again here bound moisture is kind of moisture which is normally mixed with the cell wall of the chemical substance, is mixed with the cell wall of the chemical substance. Which is difficult to remove, since it is a bound form, which is contains in the grains as a bound form. Unbound moisture is excess amount of or more amount of moisture content than bound moisture. Okay, but normally that unbound moisture is more than bound moisture. Generally the grains are not found in that stage when the unbound moisture may exist in it. Okay, so sometimes it's also called as a free moisture, and free moisture is a normally that excess amount of moisture which is more than EMC, equilibrium moisture content. Whatever the moisture present in is called excess amount of equilibrium moisture content is free moisture. So these three types of moisture. In case of unbound moisture also, and unbound moisture, that vapor pressure of that moisture is exactly equal to the pure vapor moisture. The whatever the water present in unbound condition is unbound condition, at that stage vapor pressure of that moisture is equal to the vapor pressure of pure water. Okay, this is three terms. If you see the graphically, or the three moisture can be represented in a same graph. You know that EMC curve looks like this way. Okay, so from that you can show that other moisture as well. So here up to this one there is a up to this EMC, and this up to that moisture is a equilibrium moisture content, also represent as a XE. Okay, here the curve, this axis represent relative humidity, that axis represent moisture content, which is called kg of water vapor divided by kg of dry solid or dry matter. This is in percentage. Okay, percentage. Also it is called dry basis, since it is a dry solid, so dry basis. Okay, so that first moisture is called EMC up to this one. So after that, up to this moisture is called free moisture. Okay, and here this another line. So up to this EMC curve, that is your bound moisture. And since the more amount of moisture than bound moisture is called unbound. This is your unbound moisture. So initially once you start drying, so free moisture will be removed. Within this free moisture there will be that unbound also containing free moisture. Once bound moisture, there may be also content of the free moisture as well. So some amount of moisture cannot be removed. So for example, of paddy, so we stored paddy as 12% moisture. Okay, that is storage moisture content of the paddy. So within this one there may be some bound moisture. Okay, there may be some free moisture. Below, then you can below this 12% you can dry, but this is a safe storage. So it's a combination of bound moisture and some amount of free moisture. Okay, this is all about your different types of moisture. Okay, now we'll go to the drying process. Okay, Next topic will be your drying process. This is the main drying behavior, main drying process here. So what is drying process? Actually, we know that all agricultural commodities or any food products mostly porous, mostly all are porous. So there is a chances of flow of water within these porous materials. Okay, with the application of heat or any drying medium, then the movement, moisture movement will be through the porous medium or porous condition. Okay, so normally this due to the diffusion of water through this. So what due to this diffusion is flow of water, diffusion of water through porous medium, that is your drying process. Okay, so here there that drying process is responsible for two factors. Basically it is responsible for two factors. Okay, one is your vapor pressure gradient, one is your vapor pressure gradient. Gradient, you know, there is a difference of two vapor pressure which can create a gradient or thrust for flow of vapor from high vapor pressure to low vapor, from high vapor pressure to low vapor pressure. So normally drying occurs due to that condition. So say this is a grains or any grains, if you apply heat, so if the surroundings have low vapor pressure and grains have high vapor pressure, there will be a tendency of flow of water vapor from the grains to the atmosphere. If the grains have two bone dry materials, since it is a hygroscopic nature, so vapor pressure of atmosphere is high, vapor pressure of grains is low, so the grain will absorb moisture from the surroundings. Okay, next your another this is first factor. Second factor is your diffusivity. Second factor is your diffusivity. Okay, diffusivity. So due to that vapor pressure gradient, that means your slope, also called slope, that diffusivity, flow of water takes place. So these are the two factors which is responsible for your drying process. So now come to the drying behavior, how it behaves with respect to the movement of moisture, with respect to the drying time. Okay, there is a three relationship between all these drying parameters. So first relationship between your this parameter, which is also called drying curve. Drying curve. The drying curve is a simply the relationship between the plots between the relationship, that is your moisture content. One is your moisture content versus drying time. Moisture content is percentage, moisture drying time is your hour. Okay, the first relationship. Number two is your drying rate. So drying rate will represent kg of water vapor per hour versus your drying time. This also a hour. The third relation is your drying rate, which is also kg per hour versus moisture content. Okay, these are the three relation. So the plots of these three relationship is collectively called as a drying curve. Okay, so if any questions like what is drying curve, you can say the relationship between the moisture content versus drying time, drying rate versus drying time, and drying rate and moisture content is collectively called a drying curve. Okay, so we'll see now the three types of curve, how it behaves, which will directly clear to you as a drying process. Okay, so first relationship between your that is a drying process also clear here. The first relationship between the moisture content versus drying rate. The first relationship also called drying rate, drying behavior, this curve. Okay, here the relationship between this is axis is your moisture content in percentage. This is also called kg of water removed per kg of water vapor present in kg of dry matter, which is also called dry basis. Okay, now here this axis also, this is this axis called drying rate, unit is kg per hour. Okay, since